Hello all. So the very simple definition or work is that we say that work is done in physics. Particularly we say that work is done when there is some displacement along the direction of the force which is acting on the object. So it means that there must be some displacement along the direction of the force which is acting on the object. That means if there is no displacement along the direction of the force, in that case we say that there is no work done by that force. There may be displacement in the object, but if it is not along the direction of the force acting, then we say that work done that force is zero. So work done, it can be zero in different situations. First one is that if there is no force. If there is no force acting on the object, work done is zero. Second situation where the work done can be zero, it is because there is some force but there is no displacement which is happening. Let us take a simple example. Suppose that there is a truck lying over the road and one person is trying to push the truck, but there is no movement in the truck or there is no displacement in the truck. So that simply means that there is the force, but that force is not able to cause the displacement. That force is not sufficient to cause the displacement. That means displacement is zero, and when displacement is zero, the work is also zero. So here, because there is a force but there is no displacement happening in the object, so therefore work done is again zero. There can be third situation where the force is acting and there is some displacement. How is that? There is a force but displacement is happening in a direction which is perpendicular to the force. So that means if there is some force, right? For understanding this, I want you to observe this diagram, very first diagram on the left hand side, very carefully. So there is some force which is acting on a point. For example, we have an object here and there is some force which is acting along this direction, right? Now the displacement, it can be along this direction. Now this is not the displacement which is happening along the direction of the force. Then what is the amount of displacement? For finding the displacement, we just draw the perpendicular from this point here. So only this length, or we can say this displacement, is out of this whole displacement. Only this part of the displacement is along the direction of the force, right? And whenever displacement again takes at a wider angle than the force, this angle was less and now this angle is quite more, then the displacement is along this direction. Now this is not the displacement caused by this force. Then what amount of displacement is caused? For that we draw the again perpendicular from this point on the force direction of the force. So this is a perpendicular here again. Now this length is only the displacement which is caused by this force. So here, because this force is same but displacement is comparatively less along the direction of the force, so therefore work done is, amount of that work is less. Now suppose that displacement is taking place at right angle to the force, means perpendicular to the force. That means there can be no length of the displacement or no part of that displacement which is along the direction of the force. So therefore this we can understand like that there is this displacement, it is not caused by this force. There may be some other force which is causing this displacement but not this one. So the force, this force is doing a zero work in a perpendicular direction. So there can be no force which is acting in one direction and the object is moving in a perpendicular direction. I have just simplified this diagram into this. There is one force and displacement is happening along perpendicular direction. So it is a perpendicular. So that means work done by this force is zero, right? So this displacement, it is actually not done by this force. So this force is able to do the work only along its own direction. Let me take a practical situation. You think about this stone which is tied with a string and it is being rotated by a child in a circular path. Then what happens? There is some force, tension force, which acts towards the center of the this circular path in which stone is being rotated, right? So this tension force, it is always directed towards the center of this circular path. wherever is the object may be here, 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 or here. The force is, tension force is always directed towards the center of this circular path. Suppose that stone is having anti-clockwise motion, or I can say motion in anti-clockwise direction. So it simply means that it can have at this point. If we find this object to be lying over this point, at this point direction of motion is, it is given by along this direction. So displacement will be, direction of that displacement will be taken along this direction, which is tangent to this circle, right? And this force which is acting already towards the center means along the radius and radially inward, right? So this force has to act along the radius towards the center always. So that means this displacement, it is at right angle to the radius, the force which is already along the radius towards the center. So that means there is a I can say that displacement is at perpendicular direction to this force which is acting towards the center. So that means this displacement, it is not caused by this force, right? So we say that the work done by this force is 0. You can think about another example. Suppose that this is a satellite which is revolving around the earth. So earth is at this center O, and this satellite is revolving around this earth in anti-clockwise direction. So at any point, the direction of motion of the satellite, or we can say the direction of displacement of the satellite, will be along the tangent line drawn at that point. So this is the direction of the motion at this point only. If it changes to here, the direction will again change. So this will be the direction of the displacement of the particle, or we can say satellite, at this point. And the force which is binding this satellite to the earth, so that this satellite does not leave the this orbit of the satellite around the earth. If it leaves this orbit, then the orbit will be lost in the space. So there is force which is always acting from the satellite and directed towards the center of the earth, and this force, it is called as the gravitational force. Here, in case of circular motion, any force which is acting towards the center, it is called as the centripetal force. So here this centripetal force is nothing but the gravitational force which is acting on this satellite. So the function of this force is only to keep this satellite over the circumference of the circular orbit. So this is only the function what this force does, right? So if this force is keeping this satellite over the circumference, means distance of this point from the center always remain same, equal to the radius. That means this force which is directed towards the center, it is not causing any displacement towards the center, right? Only the displacement is happening along the tangent line. So that means this force is doing 0 work on the satellite. So this is what we mean by 0 work whenever displacement is happening at right angle to the force. So for this force, for that particular force, the work done is 0 because there is no displacement along this direction. Had there been any displacement along this direction, there will be some displacement, but known by drawing the perpendicular, just as we have did in first diagram. So there would have been some displacement, but in this particular situation there is no displacement because displacement is at right angle to the we can say the centripetal force or the force. It is because the tangent line, it is always perpendicular to the radius. So here force is along the radius towards the center, and the displacement, direction of displacement is this, which is along the tangent at any position of the satellite on the circular orbit. So in this situation, force Fc, or here it is the gravitational force, it is not causing any displacement. So this displacement is caused by other forces but not by this force. So this is what we understand about the 0 work by a force at a perpendicular direction to the displacement. Thank you.